Atomism is a natural philosophy that developed in several ancient traditions. The atomists theorized that nature consists of two fundamental principles, atom and void. Unlike their modern scientific namesake in atomic theory, philosophical atoms come in an infinite variety of shapes and sizes, each indestructible, immutable and surrounded by a void where they collide with the others or hook together to forming a cluster. Clusters of different shapes, arrangements, and positions give rise to the various macroscopic substances in the world. References to the concept of atomism and its atoms are found in ancient India and ancient Greece. In India, the Jain, Ajivika and Karvaka schools of atomism may date back to the 4th century BCE. The Nyaya and Vaisheshika schools later developed theories on how atoms combined into more complex objects. In the West, atomism emerged in the 5th century BCE with Leucippus and Democritus. Whether Indian culture influenced Greek or vice versa, or whether both evolved independently, is a matter of dispute. The particles of chemical matter for which chemists and other natural philosophers of the early 19th century found experimental evidence were thought to be indivisible, and therefore were given the name atom, long used by the atomist philosophy. However, in the 20th century, the atoms of the chemists were found to be composed of even smaller entities, electrons, neutrons, and protons, and further experiments showed that protons and neutrons are made of quarks. Although the connection to historical atomism is at best tenuous, elementary particles have thus become a modern analogue of philosophical atoms, despite the misnomer in chemistry. Reductionism. Philosophical atomism is a reductive argument. Not only that everything is composed of atoms and void, but that nothing they compose really exists. The only things that really exist are atoms ricocheting off each other mechanistically in an otherwise empty void. Atomism stands in contrast to a substance theory wherein a prime material continuum remains qualitatively invariant under division. Indian Buddhists, such as Dharmakirti and others, also developed distinctive theories of atomism, for example, involving momentary atoms that flash in and out of existence. Greek atomism. In the 5th century BC, Leucippus and his pupil Democritus proposed that all matter was composed of small indivisible particles called atoms. In order to reconcile two conflicting schools of thought on the nature of reality, on one side was Heraclitus, who believed that the nature of all existence is change. On the other side was Parmenides, who believed instead that all change is illusion. Parmenides denied the existence of motion, change and void. He believed all existence to be a single, all-encompassing and unchanging mass, and that change and motion were mere illusions. This conclusion, as well as the reasoning that led to it, may indeed seem baffling to the modern empirical mind. But Parmenides explicitly rejected sensory experience as the path to an understanding of the universe, and instead used purely abstract reasoning. Firstly, he believed there is no such thing as void, equating it with non-being. This in turn meant that motion is impossible, because there is no void to move into. He also wrote all that is must be an indivisible unity, for if it were manifold, then there would have to be a void that could divide it. Finally, he stated that the all-encompassing unity is unchanging, for the unity already encompasses all that is and can be. Democritus accepted most of Parmenides' arguments, except for the idea that change is an illusion. He believed change was real, and if it was not, then at least the illusion had to be explained. He thus supported the concept of void, and stated that the universe is made up of many Parmenidean entities that move around in the void. The void is infinite and provides the space in which the atoms can pack or scatter differently. The different possible packings and scatterings within the void make up the shifting outlines and bulk of the objects that organisms feel, see, eat, hear, smell, and taste. While organisms may feel hot or cold, hot and cold actually have no real existence. They are simply sensations produced in organisms by the different packings and scatterings of the atoms in the void that compose the object that organisms sense as being hot or cold. The work of Democritus only survives in second-hand reports, some of which are unreliable or conflicting. Much of the best evidence of Democritus' theory of atomism is reported by Aristotle in his discussions of Democritus and Plato's contrasting views on the types of indivisibles composing the natural world. Geometry and atoms. Plato, were he familiar with the atomism of Democritus, would have objected to its mechanistic materialism. He argued that atoms just crashing into other atoms could never produce the beauty and form of the world. In Plato's Timaeus, the character of Timos insisted that the cosmos was not eternal but was created, although its creator framed it after an eternal, unchanging model. One part of that creation were the four simple bodies of fire, air, water, and earth. But Plato did not consider these corpuscles to be the most basic level of reality, for in his view they were made up of an unchanging level of reality, which was mathematical. These simple bodies were geometric solids, the faces of which were, in turn, made up of triangles. The square faces of the cube were each made up of four isosceles right-angled triangles, and the triangular faces of the tetrahedron, octahedron, and icosahedron were each made up of six right-angled triangles. He postulated the geometric structure of the simple bodies of the four elements is summarized in the table to the right. The cube, with its flat base and stability, was assigned to earth. The tetrahedron was assigned to fire because its penetrating points and sharp edges made it mobile. The points and edges of the octahedron and icosahedron were blunter, and so these less mobile bodies were assigned to air and water. Since the simple bodies could be decomposed into triangles, and the triangles reassembled into atoms of different elements, Plato's model offered a plausible account of changes among the primary substances. The rejection of atoms. Sometime before 330 BC, Aristotle asserted that the elements of fire, air, earth, and water were not made of atoms, but were continuous. Aristotle considered the existence of a void, which was required by atomic theories, to violate physical principles. Change took place not by the rearrangement of atoms to make new structures, but by transformation of matter from what it was in potential to a new actuality. A piece of wet clay, when acted upon by a potter, takes on its potential to be an actual drinking mug. Aristotle has often been criticized for rejecting atomism, but in ancient Greece the atomic theories of Democritus remained pure speculations, incapable of being put to any experimental test. Granted that atomism was, in the long run, to prove far more fruitful than any qualitative theory of matter. In the short run, the theory that Aristotle proposed must have seemed in some respects more promising. Later ancient atomism. Epicurus studied atomism with Nausiphanes, who had been a student of Democritus. Although Epicurus was certain of the existence of atoms and the void, he was less sure we could adequately explain specific natural phenomena such as earthquakes, lightning, comets, or the phases of the moon. Few of Epicurus's writings survive, and those that do reflect his interest in applying Democritus's theories to assist people in taking responsibility for themselves and for their own happiness. Since he held there are no gods around that can help them, he understood God's role as moral ideals. His ideas are also represented in the works of his follower Lucretius, who wrote on the nature of things. This scientific work in poetic form illustrates several segments of Epicurean theory on how the universe came into its current stage, and it shows that the phenomena we perceive are actually composite forms. The atoms and the void are eternal and in constant motion. Atomic collisions create objects which are still composed of the same eternal atoms whose motion for a while is incorporated into the created entity. Human sensations and meteorological phenomena are also explained by Lucretius in terms of atomic motion. Atomism and ethics. Some later philosophers attributed the idea that man created gods. The gods did not create man to Democritus. For example, Sextus Empiricus noted, "Some people think that we arrived at the idea of gods from the remarkable things that happen in the world." Democritus says that the people of ancient times were frightened by happenings in the heavens such as thunder, lightning, and thought that they were caused by gods. 300 years after Epicurus, Lucretius in his epic poem on the nature of things would depict him as the hero who crushed the monster religion through educating the people in what was possible in the atoms and what was not possible in the atoms. However, Epicurus expressed a non-aggressive attitude characterized by his statement, "The man who best knows how to meet external threats makes into one family all the creatures he can, and those he cannot. He at any rate does not treat as aliens, and where he finds even this impossible, he avoids all dealings, and, so far as is advantageous, excludes them from his life." Indian atomism. The Indian atomistic position, like many movements in Indian philosophy and mathematics, starts with an argument from linguistics. The Vedic etymologist and grammarian Yaska in his Nirukta, in dealing with models for how linguistic structures get to have their meanings, takes the atomistic position that words are the primary carrier of meaning, i.e., words have a preferred ontological status in defining meaning. This position was to be the subject of a fierce debate in the Indian tradition from the early Christian era till the 18th century, involving different philosophers from the Nyaya, Mimamsa and Buddhist schools. In the Pratishakya text, the gist of the controversy was stated cryptically in the sutra form as Samhita Pada-prak-karat-tih. According to the atomist view, the words would be the primary elements out of which the sentence is constructed, while the holistic view considers the sentence is the primary entity, originally given, in its context of utterance, and the words are arrived at only through analysis and abstraction. These two positions came to be called Ashandapaksha, a position developed later by Bhartrihari, versus Shandapaksha, a position adopted by the Mimamsa and Nyaya schools. Between the 5th and 3rd centuries BC, the atom is mentioned in the Bhagavad Gita. Kavim Puranam Manusasitaram Anoraniam Sarmanasmadhya Sarvasya Dataram Akantaya Rupam Adityavarnam Tamasar Parastat. One meditates on the omniscient, primordial, the controller, smaller than the atom, yet the maintainer of everything, whose form is inconceivable, resplendent like the sun and totally transcendental to material nature. The ancient Shashvatavada doctrine of eternalism, which held that elements are eternal, is also suggestive of a possible starting point for atomism. The atomist position had transcended language into epistemology by the time that Nyaya-Vaisesika, Buddhist and Jaina theology were developing mature philosophical positions. Will Durant wrote in Our Oriental Heritage, two systems of Indian thought propound physical theories suggestively similar to those of Greece. Kanada, founder of the Vaisheshika philosophy, held that the world was composed of atoms as many in kind as the various elements. The Jains more nearly approximated to Democritus by teaching that all atoms were of the same kind, producing different effects by diverse modes of combinations. Kanada believed light and heat to be varieties of the same substance. Udayana taught that all heat comes from the sun, and Vachaspati, like Newton, interpreted light as composed of minute particles emitted by substances and striking the eye. Indian atomism in the Middle Ages was still mostly philosophical or religious in intent, though it was also scientific, because the infallible Vedas, the oldest Hindu texts, do not mention atoms. Atomism was not orthodox in many schools of Hindu philosophy, although accommodationist interpretations or assumptions of lost text justified the use of atomism for non-orthodox schools of Hindu thought. The Buddhist and Jaina schools, however, were more willing to accept the ideas of atomism. Nyaya-Vaisesika school. The Nyaya-Vaisesika school developed one of the earliest forms of atomism. Scholars date the Nyaya and Vaisesika texts from the 6th to 1st centuries BC. Like the Buddhist atomists, the Vaisesika had a pseudo-Aristotelian theory of atomism. They posited the 4 elemental atom types, but in Vaisesika physics atoms had 24 different possible qualities, divided between general extensive properties and specific properties. Like the Jaina school, the Nyaya-Vaisesika atomists had elaborate theories of how atoms combine. In both Jaina and Vaisesika atomism, atoms first combine in pairs, and then group into trios or pairs, which are the smallest visible units of matter. Buddhist school. The Buddhist atomists had very qualitative, Aristotelian-style atomic theory. According to ancient Buddhist atomism, which probably began developing before the 4th century BC, there are 4 kinds of atoms, corresponding to the standard elements. Each of these elements has a specific property, such as solidity or motion, and performs a specific function in mixtures, such as providing support or causing growth. Like the Hindu Jains, the Buddhists were able to integrate a theory of atomism with their theological presuppositions. Later Indian Buddhist philosophers, such as Dharmakirti and Dignaga, considered atoms to be point-sized, durationless, and made of energy. Jaina school. The most elaborate and well-preserved Indian theory of atomism comes from the philosophy of the Jaina school, dating back to at least the 6th century BC. Some of the Jain texts that refer to matter and atoms are Pankastakayasara, Kalpasutra, Tattvartha Sutra, and Panavena Suttam. The Jains envisioned the world as consisting wholly of atoms, except for souls. Paramanas or atoms were considered as the basic building blocks of all matter. The concept of atoms was very similar to classical atomism, differing primarily in the specific properties of atoms. Each atom, according to Jain philosophy, has 1 kind of taste, 1 smell, 1 color, and 2 kinds of touch, though it is unclear what was meant by kind of touch. Atoms can exist in one of 2 states: subtle, in which case they can fit in infinitesimally small spaces, and gross, in which case they have extension and occupy a finite space. Certain characteristics of paramanu correspond with that subatomic particles. For example, paramanu is characterized by continuous motion either in a straight line or, in case of attractions from other paramanas, it follows a curved path. This corresponds with the description of orbit of electrons across the nucleus. Ultimate particles are also described as particles with positive and negative charges that provide him the binding force. Although atoms are made of the same basic substance, they can combine based on their eternal properties to produce any of 6 aggregates, which seem to correspond with the Greek concept of elements: earth, water, shadow, sense objects, karmic matter, and unfit matter. To the Jains, karma was real, but was a naturalistic, mechanistic phenomenon caused by build-ups of subtle karmic matter within the soul. They also had detailed theories of how atoms could combine, react, vibrate, move, and perform other actions, all of which were thoroughly deterministic. Time as explained in Srimad Bhagavatam, the material manifestation's ultimate particle, which is indivisible and not formed into a body, is called the atom. It exists always as an invisible identity, even after the dissolution of all forms. The material body is but a combination of such atoms, but it is misunderstood by the common man. Atoms are the ultimate state of the manifest universe. When they stay in their own forms without forming different bodies, they are called the unlimited oneness. There are certainly different bodies in physical forms, but the atoms themselves form the complete manifestation. One can estimate time by measuring the movement of the atomic combination of bodies. Time is the potency of the almighty personality of Godhead, Hari, who controls all physical movement although he is not visible in the physical world. The division of gross time is calculated as follows. 2 atoms make one double atom, and 3 double atoms make one hexatome. This hexatome is visible in the sunshine which enters through the holes of a window screen. One can clearly see that the hexatome goes up towards the sky. The atom is described as an invisible particle, but when 6 such atoms combine together, they are called a trasaranu, and this is visible in the sunshine pouring through the holes of a window screen. Excerpted from Srimad Bhagavatam by A.